Welcome back to Topic 2 for Algebra 1, solving word problems using the word problem format. In Part 2, we're going to look at some examples and use what we learned in Part 1 to solve these examples. Example number 1. A skate park charges $7 per session to skate and $4 per session to rent safety equipment. Jared rents safety equipment every time he skates. During 1 year, he spent $99 for skating charges and equipment rentals. How many sessions did he attend? So we're going to start off by using cubes. I'm going to start by circling the numbers. And when I circle the numbers, I'm going to also circle any context that's associated with it. So for example, $7 per session and $4 per session. We also know that he spent $99, and this 99 is referring to the total. Then we're going to underline the question. How many sessions did he attend? Then we can box any important words that we see. So the skate park charges $7 per session and $4 per session to rent safety equipment. And Jared rents safety equipment every single time he skates. Now during 1 year, so we're only thinking for 1 year, he spent $99 total. So that kind of refers, the word spent refers to that 99 also being the total for both his skating charges and equipment rentals. Now what we're going to do is define a variable. These kind of associate with the both E and S letters in the acronym for cubes. We're evaluating and solving. Let's let N equal the number of sessions that Jared skates, because that's what the question is specifically asking. We want how many. So we're going to have N represent the number, how many. Then what we're going to do is try to write an equation that uses that variable. So we know that the skate park charges $7 per session to skate and $4 per session. Oops, I actually missed a word here. Here we have and. Now this important word and, what operation does it refer to? Addition. So here we have 7 plus 4 because we're spending $7 per session to skate and $4 per session for the safety equipment. So $7 to get in and $4 for the safety equipment. Now every single time that Jared goes to skate, he has to spend this $7 and this $4. We're going to multiply this times the number of sessions that he will skate during the entire year. And we know at the end of the year, this is equivalent to a total of $99 that Jared spent. Now, using this equation, we can solve. We want to solve for a variable here. We can use what we learned in topic 1 about our different properties to solve this. So for instance, we can use the distributive property. N times 7 gives us 7n, plus n times 4 gives us 4n, and this is equivalent to 99. Now on the left-hand side, we have 7n plus 4n. These are like terms, so we can combine them. 7n plus 4n, because they both have the same variable, n, raised to the same exponent. They both have the same exponent of 1, actually. We can combine them, and we get 11n. So 11n is equal to 99. Now, since we see that this is really 11 times n, In order to undo this multiplication, we need to do the inverse. So we need to divide both sides by 11 using the property of equality. So what we do to one side, we have to do to the other. 11 divided by 11 is just going to give me my n variable, and then 99 divided by 11 gives me 9. Let's check this just to make sure it is correct. So if we plug our variable, or our newfound value of our variable, back into original equation, we'll get 7 plus 4 times 9 should give us 99. Now, if we want to simplify via PEMDAS, we can simplify in our parentheses first. So 7 plus 4 gives us 11. 11 times 9 gives us 99. So it is correct. Now we're going to conclude by writing our answer in a complete sentence using any units. So again, my question asked me for how many sessions did Jared attend? So we need to write our sentence that actually answers that question. Jared went to the park nine times that year. And there we go. Our next problem is a little bit more condensed. Here we have the sum of 3 consecutive even numbers is 246. What are the numbers? If we think about cubes, let's go on and circle our numbers first. So we know that there's 3, and we have 246. Now our question is, what are the numbers? Now we're going to box any important action or vocab words. So we have the sum. Now the sum refers to what? It refers to addition. Then we have consecutive. Now consecutive is a vocab word. Consecutive means next to. Then we have the word even, so numbers such that 2, 4, 6, 8. Then we have the word is. So is another way to represent equal to. It's equivalent. Miss Reed is the best. Miss Reed equals the best. I'm sure you've heard it before. Okay, now for evaluating, we're going to define our variables. Here, we actually have 3 unknowns because we want 3 consecutive numbers that give us a sum, when we add them together, of 246. Since the numbers are consecutive, we know that they're next to each other. So for example, 3 consecutive even numbers could be 2, the next even number would be 4, and then 6. But however, when we add these 3 numbers up, we should get 246. Whereas when we add these 3 numbers, we get 12. So it's not these 3 numbers, but instead it's a little bit bigger. So how can we represent this with a variable? Let's let x equal the first even number. Now, our next even number, for example, if x is 2 here, in order to get to 4, how much do we have to add on it to jump to 4 on the number line? We have to add 2. So our next variable is going to be the quantity x plus 2. This is our next even number. our third and final even number, if x is 2, to get to 6 in this example, we have to jump 2 and then 2 again. So we have to jump a total of 4 spaces on our number line. So this is going to give us x plus 4 as our following even number. Now we know that the sum of these 3 even numbers is 246. So if we want to write an equation, we know we can take x, our first number, add it to x plus 2, our second even number, and then add it to x plus 4, our third even number. When we add these all together, we'll get our total number of 246. Now, looking at this equation here, we want to combine our like terms. So we know we have x, x, and x. If we add them together, x plus x plus x gives us 3x. Then if we still look on the left-hand side and we look at our constants, we have 2 plus 4. And what I'm really doing here, in order to combine these like terms on the left-hand side, I'm really using the associative property because I'm associating different like terms with each other. Now 2 plus 4 gives us 6. So 3x plus 6 gives us 246. Now in order to solve for x, because that is our unknown, we need to use the property of equality and subtract 6 from both sides. Because what we do to one side, we have to do to the other. Here, we're left with 3x equals 6 minus 6 is 0 because they're inverses, and 246 minus 6 is 240. Now we have 3x equals 240. This is really 3 times x. So in order to undo this multiplication, the inverse is division. So here we're going to use the division property of equality and divide both sides by 3. On the left-hand side, the 3's reduce to 1, or just 1x, also known as just x. On the right-hand side, we have 240 divided by 3. This gives us 80. But wait, we're not done yet. This just tells us what the first even number is. We still need to find the next even number and then the following even number, because our question asks for 3 numbers that you add together to get to 246. 3 consecutive even numbers that we add together. So, if x equals 80, x plus 2 must give us 80 plus 2, or 82, and x plus 4 should give us 80 plus 4, or 84. Now let's check to make sure when we add these 3 consecutive even numbers together, we get our sum of 246. So 80 plus 82 plus 84. If we add them together, 80 plus 80 is 80 plus 82 is 162. Plus 84 gives us 246, which is correct. Now we have to write our final answer in a complete sentence. So the 3 consecutive even numbers are 80, 82, and 84. And that was part 2 for topic 2 for Algebra 1, solving word problems using the word problem format. Thanks for watching.